Here's a 2.2. It says, the garden boy wants to expose a flower to the sun. He decided to mount a string from the flower bucket to the wall, which is then supported by the metal attached to the wall, such that the flower bucket is stationary. So we know stationary means that it is at rest, it is not moving. The combined mass of the bucket and the flower is 2.5 kgs. The metal is mounted such that it is perpendicular to the wall, and the angle between the string and the metal is 30 degrees. So we have three main components here, or three main forces. And we start off by identifying that main point that is going to experience all three forces. So for this particular question, this is our main point. So this is the point at which all the forces are going to be acted on. Okay, so starting off with the mass of the bucket, we know that gravity is going to pull this bucket down, so we're going to have weight, or Fg, force of gravity, acting downwards. Next, we have tension in the rope, so tension is going to go this way. And now, what about the force in the metal? So the force in the metal can be seen as an applied force, but the direction in which it is applied is really important. So generally we draw these arrows as if they are radiating, right? So all of the tails are radiating from the central point. However, in this case, the force that the metal is exerting on the central point is acting to the right. So there's two ways of drawing it. You can draw it where you have the arrowhead acting on the dot, but also we need to understand why, okay? Think about the way in which this force is being exerted. Without the metal in place, the string would just hang straight down. It would be vertical. But this metal now pushes the string. So this is actually a pushing force. It pushes the string such that it causes the string to bend at this point. So a pushing force will be directed on the object. So you can draw the arrow like this, but the more correct way would be to draw it going to the right here, where you have the tail. Remember, when you draw your diagram to start off with, all of your tails basically touch each other. Okay, so they radiate from your central point. Now this diagram here is just for you to understand what's going on and to understand the forces that you're working with. Here you can call it Fm, Fa. I'm just going to keep it as Fm, it's the force of the metal, but it's also our force applied. So if you say Fa, that's perfectly fine. Now let's look at 2.2.1, calculate the weight of the bucket. Remember that weight is another term for Fg. So when we are asked to calculate weight, that is exactly what we're calculating, Fg. So your formula is Fg is equal to mass times gravity. Now the mass of this bucket together with the flower was given as 2.5 kgs. Gravity is 9.8. Let's calculate. That gives us 24.5 newtons. So that is the weight of this bucket together with the flower, which they refer to as the bucket system. Now 2.2.2 says draw a closed vector diagram including at least two angles. Now remember that a closed vector diagram is going to form a triangle. It is drawn head to tail. So we need to arrange these arrows that we have such that we can draw a triangle head to tail. You can choose which arrow you want to start off with, so which vector you want to start off with. I am going to draw Fg first, so I'll use that as my starting point. So here I've started with Fg, and we can see Fg is going straight down. The next force I'm going to draw is the force of the metal, which is going to the right. Now remember, it has to be a head to tail method, meaning that the arrowhead of the one vector needs to touch the tail of the next vector. So here we have the tail of Fm touching the arrowhead of FG. And the last vector that we have is tension. So again, the arrowhead here of FM is going to touch the tail of tension, and the arrowhead of tension is going to touch the tail of FG. So this is our head to tail diagram. Now they specifically said that they want you to include at least 2 angles. So firstly, we know that this is a right angle triangle, so let's fill in that symbol. Then we're also given this 30 degrees, which lies in this corner of the triangle, so let's fill that in. Okay, so here's our closed vector diagram. 2.2.3 says, explain the meaning of a closed vector diagram. So we'll write it down just now, but let's just understand what this is. We know that we need certain conditions to be met in order to draw a closed vector diagram. That is, the system must be stationary, so it must be at rest. We also know that for a closed vector diagram, we need to draw all the vectors using the head to tail method, as I've explained. And also, what is the purpose of a closed vector diagram? It shows you that the magnitude of the net force acting on the system is 0. Because remember, the system is stationary, so there is no acceleration. So 2 things are required. 2 main things are required here. Let's write this down. So it says a closed vector diagram is a set of vectors drawn using the head to tail method, and that has a resultant with a magnitude of 0. So you know that the resultant is the same thing as F net, the net forces acting on the system. Please remember to like, subscribe, and turn on your notifications for more content.